Welcome to EDU World Space.
The only difference between a one-tailed test and a two-tailed test is the critical region that we use for our test. If we look at the first example in blue, we see that we are testing to show that mu is not equal to 100. So the critical region, if we were to do a 90% confidence interval or 90% alpha level, would be having 5% on either end of this bell curve. So if we had a 5% shade on the left and 5% shaded on the right, if any of, so this middle area would be 90% of the area. If our test statistic ends up being in the shaded region on either side, then we will reject the null hypothesis. So this one would be a two-tailed test. The reason for this is that it does not matter whether it's lower than 100 or higher than 100. If it's far enough away from 100, then we will conclude that mu is not equal to 100. Now if we look at the second example, these are both going to be one-tailed tests, the red and the green. But the red example specifically wants mu to be greater than 100. So again, we will make sure that the center area is 90% of the area. And this time we would accept anything in the top 10% of the bell curve. And so this would be 10% right here. Whereas with the two-tailed test, we would only have 5% on each side. So anything that lies in the shaded red region would be enough for us to conclude that mu is greater than 100. Finally, for the green one, we would want mu to be less than 100. And so we would want something in this shaded region. And the way that we differentiate between the red example and the green example is that the red one would be called a right-tailed test. And the green one would be called a left-tailed test. Again, these are entirely dependent upon the hypotheses that you choose, and it will just depend on the situation, what it is that you're trying to prove. So these are both one-tailed tests. And finally, the definitions of each one-tailed and two-tailed would be as follows. A one-tailed test should reject the null hypothesis when the test statistic is in the critical region on the appropriate side of the mean, either the left or the right side. So it could be a right-tailed test or a left-tailed test. And a two-tailed test should reject the null hypothesis when it lies in the critical region regardless of which side of the mean that it lies on.